Hello everyone, welcome to the shop. What you see spread out before you is the components for the Hemingway Trent Pinion Mill casting kit. For those of you unfamiliar with this machine, it's basically a specialized horizontal knee mill designed for cutting small steel pinions. Some of you might be familiar with this machine in passing. Personally, I sort of lusted after it for quite a while. Always wanted to build this thing. If you want to learn some more details about it, head over to Hemingway's website and check it out. It's a neat little machine that has an interesting history, and I think will be a really useful machine for me here in the shop as well. Now, normally I wouldn't spend this kind of money on a project sort of kit of stuff to build something, but this is a machine I can legitimately get a lot of use from in the shop, and it was also a very generous gift from family members for my birthday. I'm not sure if I ever would have purchased it for myself. I've certainly been tempted in the past. As far as the experience with Hemingway as as a customer of theirs, dealing with them as a company, is very pleasant. No complaints. This was ordered and then arrived from England. I believe it was within a week. Pretty darn quick. I did email with Kirk over at Hemingway a little bit. Seems like a real nice guy, and this packaging wise, this was packaged extremely well. You can't see the box here. The box was plastered in DHL packing tape, indicating that it had been repackaged. So I was kind of nervous when I got the package. I expected things to be all, messed up and or missing. But it was fine. Everything accounted for, nothing damaged. As far as castings, there's only a handful here. The column, which will have the dovetails here for the knee. The knee itself. And the headstock and tailstock for the indexing work holding mechanism. You can kind of see here in the picture. The bed or table is not actually a casting at all. It's just made from a piece of cold rolled mild steel. I do have a length of Durabar that I could use instead, but I don't think I'm going to. I think I'm going to stick with the mild steel for that. And the only other cast iron piece is the pulley. This is what appears to be a slice of continuous cast iron, like Durabar, if you will. The base plate that the column mounts to, that the machine sort of sits on underneath here, that's just a 1/4-inch thick plate of mild steel as well. One of the things that impressed me the most about the stuff that was sent as part of the kit was the documentation. And Randy Richard, I'm sure you're all familiar with him and his YouTube channel. He's recently built a couple of Hemingway kits, and he made the comment that the drawings that came with them are just fantastic. And he's absolutely right. I mean, they're super nice. Give you a quick look here. If you want a more detailed look, you'll have to buy the kit. I think they sell the drawings separately as well, and this honestly wouldn't be all that difficult, well, all that much more difficult to build from bar stock. In fact, the machine that this was based on, the Kronos Pinion Mill was designed to be built from bar stock. Well, the drawings are excellent. What really blew me away that I didn't quite expect. I knew it came with some build documentation, but I didn't expect it to be this thorough and detailed and well written. This is written by Alan Timmins. I believe he's the guy who revamped the original Kronos design to become what is now the Trent Pinion Mill. And it reads like a magazine article. Perhaps it was at one point. Not only is it step-by-step build instructions that are well written, it goes out of its way to tell you why you're doing things particular ways and refer to other parts in the document where there will be steps related to the step you're performing. And there are even some alternatives you can take to some of the steps that are explained. I definitely appreciate that. That makes this very achievable project, I think. One of the kind of oddball things that I didn't expect with this, and I think Randy mentioned this in one of his videos as well. I want to say it was for the radius turning attachment. The units are mixed. Most of the dimensions in the drawings are imperial. The only dimensions that aren't are clearance holes for some of the fasteners, for example, because the fasteners are all metric. The feed screws, of course, are metric. I knew that going into it. That's fine. I'm going to probably be using this machine for the most part to cut module system gears and pinions anyhow. But it sort of rubs me the wrong way mixing metric hardware with the imperial dimensions. There's a few of the threads. I believe it is the indexing spindle drawbar and the collets all have imperial threads. And those are threads that I would be more apt to want to single point. Since I can only single point imperial threads in the shop with the equipment I have right now, since I don't have transposing gears for either of the screw cutting lathes that I have, I'm pretty much resigned myself to changing things up and using imperial hardware with the machine. The hardware that came with it's pretty nice, especially the screws. But I have a thing for making screws and fasteners, as many people who who know me, and probably many people who have been following me could have guessed. I'll take pretty much any excuse to make some screws or bolts for something when it's totally not necessary. I don't know, I just enjoy it for some reason. So putting all this work into a machine like this, I just don't see myself, using the out-of-the-box hardware store fasteners, even though they are rather nice. If I'm going to make them anyways, I might as well make them imperial. I've got a really complete selection of imperial taps and dies. I can single point the imperial threads. It just makes a lot of sense. I'm going to keep the feed screws metric, as I mentioned. The major change that I'm going to make to the design, where I'm really going to deviate, and I've been spending a lot of time thinking about this to come up with a plan that will not affect any of the design around my changes. I want to keep the changes very surgical. I'll get into more details about it later, but I was inspired by some of the Horth equipment that I have that has this real slick combination screw feed, lever feed configuration. And it's pretty simple in concept. If you look at the end of the table where this retaining plate is, this retaining plate that also carries the bearing for the screw feed along the table axis, if it could be decoupled from the table, then the table will slide free and the screw can stay right where it is. And that's really the heart of this. Sort of ancillary to that, you obviously have to have a lever mechanism attached to this. And finding a place to do that where it won't be in the way might be a real challenge. I may mount most of the mechanism permanently and then have a way to quickly remove the bulk of the handle just to get it out of the way for when I'm not using it. But the key is really in here, having a quick toolless way to decouple the screw feed at the carrier here from the table. There's a couple ways to do this, and I'm leaning pretty strongly towards one particular method just because for me, with what I have in the shop here, it will be a lot easier for me to manufacture. So as I say, I'll get into more details about that later, but effectively we'll end up with a mechanism where a lever or thumb wheel or some such thing can be loosened to disengage this screw feed plate from the table, yet still retain its location so that when it's re-engaged you don't have this screw off its axis at all. That'll probably make a little more sense as we get to that point. For now, I'll just be happy to start making some chips on this thing. I've had the kit here for a little while, and I've spent a lot of time thinking about the design changes, going over the components, reading through the documentation, and just generally being sort of excited about it. One thing that's going to really draw out this project a lot longer than it needs to is that I'm going to scrape the bearing surfaces, all of the slideways on this machine. I've done a lot of, well, not a lot. I've done several flat surfaces in the past. I've had a decent amount of practice. Never had formal training, of course. I would love to someday. This will be a great opportunity for me to get some practice with some more involved geometry, obviously inside the dovetails. And not only that, but get a feel for scraping very closely interrelated geometry. For example, the ways on the column here need to be perfectly square to the ways on the top of the knee for the table. This is a very small machine, as you can tell by the parts. Absolutely tiny. So as far as practice with that sort of thing, I think this will be a good one. My one kind of hang up with all that is that I don't have a gauge that can fit inside the dovetails right now. And I've been sort of threatening to make one for the longest time. There are a few compound and cross slides for some of the lathes that I have that I really would like to rescrape, and I would have the same issue there, not having a way to get a gauge in there to glue up. So I have this hunk of cast iron here that I'm going to be turning into what's I believe known as a prism gauge. So this will have an angle that is accurately scraped and will fit into the dovetails that I can use for bluing up the male and female dovetails. If you read through the documentation that comes with the build instructions, they suggest, maybe this isn't the right term, but lapping all of the all of the dovetailed surfaces together, by using an abrasive compound in the dovetails and working them back and forth as you sort of progressively snug up the gibs. And that probably works fine. I've never tried it myself. I've always been a little too afraid for fear of the abrasives embedding in the the slide parts themselves. And I'm sure if you're an abrasives nerd, you'd know exactly which abrasives to use on which materials to keep them from becoming embedded. But since I want to scrape them anyways, it's really irrelevant, I guess. But I guess just the point being that scraping them totally isn't necessary. And it's just, it's all about the level of effort that you want to put into the machine. And that's, I think, kind of what makes these kits like this great. So I think that if you wanted to build one of these and, weren't really interested in doing any of the unnecessary stuff like the combination screw lever feed, scraping the ways, it really wouldn't have to take a terribly long time. I think most of the work is going to be in the setup operations. And this is the kind of project, I'm sure, where if you start to get in a little bit of a hurry, you're going to pay for it for sure. So the idea here is I'm going to take my time, try to make the best little machine that I can out of it. And I will mention that the reason I want to do a combination lever and screw feed is because, as I sort of alluded to earlier, I want to use this machine not only for cutting pinions, but wheels as well. Particularly small wheels, gears, if you will, for pocket watches and small chronometers. Cutting brass wheels, because they're, first of all, the material brass, the fact that they're thin, and the fact that you have so many more teeth to cut than, your typical pinion, lever feed's really the way to go. Otherwise, you're forever cranking on the handle. That gets old real quick. Lever feed is just dynamite for a lot of things, and cutting brass gears is one of them. On the other hand, pinions are not a lot of fun to cut with lever feed at all, due to the amount of material being removed between each tooth and the fact that you typically would make pinions from steel. So that's really the motivation behind taking the extra time to modify this design for a combination screw and lever feed, so that it's a really nice machine to use for both gears and pinions. So I'm sure I'm leaving something out or not addressing something that probably seems obvious to cover. It's late, it's been a long week, feeling kind of run down. So anything I've overlooked, definitely just hit me up in the comments section. I try pretty hard to respond to everybody's questions in the comments. What I think I'm going to do next is start with some of the first steps, which involve the base plate and the, can't really see here, but what they call the knee nut support. Little post that comes out of the plate supports the nut for the knee screw. So we'll see what kind of progress we can make, and onward and upward. As I mentioned, the base plate starts out as a piece of 1/4 inch thick cold rolled steel plate. Off camera I started by just draw filing the edges square and beveling the top surface. I also did a quick scraping job on the top surface. You can see I've also laid out one side of the plate with the hole locations for retaining the column, the knee support, and for attaching the base plate itself to the work surface or bench. With the work set up on a pair of parallels with the scraped surface down, we're just going to drill out the holes from the bottom side of the plate. Quick idiot check here for the hole spacing with my calipers. We're going to drill the 4 holes in each corner for mounting the plate down to a bench or work surface, and the 4 holes that are inboard set to the rear of the plate to hold the column in place, and the 3 that hold the knee support in place will be left until after the knee support is made. They will be drilled with the knee support itself actually in place to ensure alignment of all the screw holes. The drawing calls for the column holes to be countersunk 90 degrees, but instead I'm counterboring them here so I can use what are known as cheesehead screws. Lastly, we're going to drill and bore a 5/16 inch diameter hole that will be for locating the knee support later on. I'm using my shop-made miniature boring head here. It takes 1/8 inch round boring bars. That's all for this part. I know it was sort of light on machining content, but I promise a lot less yakking and a lot more making chips in future parts. Stay tuned. And thanks for watching.